Hello everybody, welcome in this new video. Today we're gonna speak together about hydraulic motors. So first, let us discover the chapters. We have different forms of energy, hydraulic system, types of actuators, what is a hydraulic motor, comparison between electric and hydraulic motors, types of hydraulic motors, radial piston motors, crankshaft and radial piston motors, working principle of same motors, applications of hydraulic motors, case study and questions and answers, study of radial piston motor components, assembly, testing, and maintenance of hydraulic motors. So, first, let's see the different forms of energy. We have electrical energy, thermal energy, mechanical energy produced by an electrical motor or an oil engine, hydraulic energy from hydraulic pump in the system, and mechanical energy from hydraulic actuator like hydraulic motor. Don't miss that energy loss takes place at each step of energy conversion. Now, the second step is the question. Why do we study or use various forms of energies? The answers are to suit our requirements, to make effective use of it, to control it, to make it flexible, and to preserve it. Let's now discover the hydraulic system. The basic arrangement of hydraulic systems are prime mover like electric motors or engine, the fluid reservoir like hydraulic tank, the energy transfer medium like hydraulic oil, the fluid transfer unit like hydraulic pump, the fluid transfer medium like hose and pipes, the controls like relief valves, DC valves, flow control valves, and the actuator, which are the hydraulic motor and cylinder. We are based on actuators, the hydraulic motors. What is oil hydraulics? Study of energy conversion from mechanical to hydraulic energy, pressure and flow, and again into mechanical energy, torque and speed. In oil motors, the pressure gets converted into torque and the flow gets converted into speed. Now let's see the types of actuators. We have linear actuator like hydraulic cylinder. We have oscillatory actuator like rotation motors and rotary actuator like hydraulic motor. So the hydraulic power transmission in motor are or is configured in this picture, or this is this graphic. Like you see, we have motor, oscillatory actuator, linear actuator, we have pump, we have valving, and we have prime mover. This is the graphic as you see. Now let's discover other thing, what is a hydraulic motor? It's a device which converts the hydraulic energy generated by a pump into mechanical energy in the form of torque and rotation. For a hydraulic pump, the main function is to displace as much oil as possible per revolution. To achieve this, an optimum volumetric efficiency at the cost of mechanical efficiency is required. On the other hand, the hydraulic motors have to deliver maximum mechanical power at the low point. Now let's see hydraulic motors, the graphical samples. This is the first one, like you see, this is in, out, the solid triangle, it's the hydraulic, this is the envelope, and this is the dotted line. The first sample in right, this is the unidirectional hydraulic motor, it's a fixed displacement. The second one is bidirectional hydraulic motor, also fixed displacement, and the third one is the variable displacement bidirectional hydraulic motor. Now let's know the salient feature of a hydraulic motor. We have extreme range of speed adjustment possible, torque control throughout the operating speed, low inertia, compactness of space, a fact that they can be stayed indefinitely without damage, the instant reversing of motor shaft, and the dynamic braking easily accomplished. The rapid reversal, the motor mass of hydraulic motor are less than electric motor. This is a rapid reversal. Pump, relief valve, and directional valve. This is also a rapid reversal, but with a bidirectional valve. This is relief valve and a. When we speak about speed variations, we see that electric motor have torque converters and hydraulic motor have simple flow control value. About size comparison, when we see that hydraulic motor have more power density, less power density of hydraulic motor. When we see the still performance, for electric motor have trips and stop, hydraulic motor still torque possible to achieve. When we talk about unfavorable environment, fluid motors can be used in dangerous and difficult environment. And when we talk about speed regulation, we constate that electric motors have 300%, but most the hydraulic motors have 10 to 15%. Now let's see the major applications of hydraulic motors. We have construction, mining, material handling, earth moving, plastics, machine tools, agriculture, and railway equipment. This is a special purpose vehicle using hydraulic drive and winches, like you see in the pictures. These are batch mixers, fan drives, and conveyors drives. Now, while replacing an electric motor with a hydraulic motor, we have points to be considered. We have to consider that three-phase squirrel cage electric motor have twice the starting torque of hydraulic motor. The value of the starting torque and the running torque to be known. We do not consider HP as comparison, and the details of gearbox, the pulley used at output of electric motor to be known. So let's discover again. Another thing is the classification of hydraulic motors. We have the geometry of the actuating mechanism and the speed and torque of the rating. We have two types. We have high torque and low speed motors are in two types are the radial piston motors and the orbit motor, which are devised on two types, and we have the low torque high speed motors, which are devised on three types: axial piston motors, gear motors, and vane motors. Let's discover each one of them. We're gonna begin with the gear motors. They are compact, low cost, low efficiency, between 60 and 70. The speed range are between 500 and 3000 RPM, and they cannot be used for low speed. These are a picture of gear motor. Orbit motors are also called gearing motors. They are higher power output for a given outer dimensions. They are overall efficiency low. They have volumetric efficiency low. They have low cost. Their rotation at low speeds not known, and they have higher gear. This is a picture of gear ring motor. This is another picture. Now let's discover the vane motors. These motors are designed. They are having this complicated design and manufacturing complicated. They have high cost, they have medium torque, medium speed, and the change of speed with speed torque is possible. This is picture of vane motor. Now let's discover the axial piston motors. This type of motors are low torque, high speed, complicated design, manufacturing difficult, high cost, reversing shaft output easy, speed control possible, and torque control possible. This is a picture showing axial piston motors. Like we see, we have two types: the swash plate design in this picture. This is the first design, And we have another type, which is the bent axis design, and this is the picture. Now let's discover the radial piston motors. They have high starting torque, they have high running torque, they are compact in size, specific torque high, they are bidirectional, they have low speed possible, less than 10 rpm, torque variation possible, they have low noise, the vibration very low, they have high mechanical efficiency, they have high volumetric efficiency, and they have instant reversing possible. This is the first type of radial piston motors, which is the crankshaft design. This is the picture showing a radial motor, radial type distributor. This is another picture showing radial piston motors. They have swiveling cylinder and double piston support bearing. This is also a radial piston motor, another picture. This is another picture of a radial piston motor. Now we turn to another thing, which is the motor ratings. What are the ratings of a motor? The rating of hydraulic motors are done based on the following operating parameters: the displacement, the torque capacity, the speed, and the operating pressure. First, the displacement of a hydraulic motor is defined as the amount of fluid required to turn the motor shaft. The second parameter is the torque, is the running force developed at the motor shaft due to its rotation. The value of torque increases with increase in operating pressure and decreases when the pressure decreases. The third parameter is the speed of hydraulic motor, depends on its displacement and the flow rate to it. And the last one is the operating pressure. The pressure required by the hydraulic motor depends on the torque requirement and its displacement. So now let's know how we choose a motor. The motor selection. We have to know these parameters or characters, like output parameters, speed and torque, motor parameters, displacement, hydraulic parameters, the flow and the pressure, the torque parameters, which are displacement, and the speed parameters, which are flow. And finally, now let's see the effect on hydraulic motor during change in hydraulic settings under constant load condition. So when we increase pressure setting, we increase torque availability. When we decrease pressure setting, we decrease torque availability. When we increase flow, we increase speed, and no effect on the other parameters. When we decrease flow, we decrease speed, no effect to the other parameters. When we increase displacement or size, we decrease the speed, we decrease the operating pressure, and we increase the torque availability. And when we decrease displacement, we increase the speed, we increase the operating pressure, and we decrease the torque availability. Thank you for watching this video. If you like it, don't forget to put like and to subscribe to channel to receive all my videos. Thank you and goodbye.